Astronomers have been able to reconstruct the three-dimensional structure of an interstellar cloud, an extremely difficult feat thanks to one incredible characteristic: the cloud is ringing. Everything in the universe is shaking and vibrating, but this nebula is doing something more: it's making music. The cloud is known as the Musca molecular cloud, a dark nebula in the southern sky that looks a bit like a needle. Researchers Aristritsis and Konstantinos Tassis from the University of Crete noticed that Musca was surrounded by striations, hair-like filaments of gas, that appeared regularly distributed. The regularity is the key. In Musca, these striations are produced by trapped pressure waves created by magnetic fields. It might be different in origin, but they behave exactly like sound waves from a musical instrument. The team was able to detect the harmonics of this cosmic symphony and without the structure of the cloud. Musca only appears needle-like because we are seeing it from the side. The cloud is actually a vast sheet-like structure 26 by 20 light-years, and it's about 5 light-years thick. The size of the structure is certainly unexpected, and even though there's some uncertainty because we can't place the distance precisely, the wide shape is correct. Musca is between 500 and 650 light-years away from us. The research represents an important step forward in our understanding of giant molecular clouds. These objects are the birthplace of stars and planets, and many of our theories rely on how these objects behave. Everything we see in the sky is a two-dimensional projection of a 3D object, so there's a chance that our models might not completely describe real stellar nurseries if we are missing information about their structure. For decades, the determination of the 3D shapes of clouds has been pursued through statistical studies, which do not provide information on a cloud-by-cloud basis, the researchers write in the paper, published in Science. Other proposed methods rely on complex chemical and/or radiative processes and thus depend on numerous assumptions. With its 3D geometry now determined, Musca can be used to test theoretical models of interstellar clouds. Testing the models will help astronomers get a more precise view of how many and what type of stars form in the Milky Way.